Welcome to Episode 48, Contingency Planning Part 4. In this final segment, we explore what it means to mature continuity capabilities so that resilience scales with the organization. Mature programs move beyond manual procedures toward automation, orchestration, and measurement. The goal is continuity that operates quietly in the background, adapting to growth without becoming brittle. Each enhancement, from automated backups to cross-region replication, adds consistency, speed, and verifiable assurance. Maturity replaces heroics with reliability. Continuity is no longer a reactive exercise, but an embedded system that learns, measures, and improves after every test and event. When continuity scales, it frees people to focus on recovery decisions, not the mechanics of recovery itself. Building on that foundation, automating backups with policy enforcement ensures that protection becomes consistent and auditable. Automation reduces the human error that often undermines manual scheduling or selection. Backup policies should define scope, frequency, retention, encryption, and validation, then apply uniformly across all managed systems. For example, when a new database is deployed, automation should detect and enroll it under the correct backup plan immediately. Logs and dashboards provide real-time visibility into compliance, showing exceptions that require attention. Policy enforcement is both shield and evidence. It guarantees coverage today and proves control tomorrow. When automation carries the routine, people can concentrate on verifying results rather than repeating tasks. From there, cross-region replication and consistency guarantees deliver resilience beyond a single facility or provider. Replication copies data continuously or at scheduled intervals to geographically separate regions, protecting against regional failures or large-scale disasters. Consistency guarantees, whether synchronous, asynchronous, or point-in-time, determine how accurate and current those copies remain. For instance, financial systems may require synchronous replication for zero data loss, while analytics workloads may tolerate slight delay to reduce cost. Monitoring tools should confirm that replication jobs complete, lag remains within policy, and integrity checks match source data. Cross-region strategy turns recovery from relocation into redirection. Systems simply shift to healthy regions without missing a beat. Continuing the journey, application-aware backup and quiescing address the hidden complexity of modern workloads. Quiescing temporarily pauses or stabilizes applications during backup to ensure data consistency across memory, cache, and disk. Application-aware tools communicate directly with databases or services to capture coordinated snapshots rather than independent fragments. Imagine a backup that includes a database, its logs, and connected application state all synchronized at one moment. Recovery then restarts seamlessly without data corruption. These methods require tuning but pay dividends in predictable restorations. Mature programs treat backup not as a file copy, but as a holistic preservation of working systems. From there, orchestrated failover and runbook validation transform disaster recovery into a controlled process rather than a scramble. Orchestration tools automate the sequence of failover actions, starting systems in the right order, reconfiguring networks, and validating health checks automatically. Runbooks, embedded within orchestration, document dependencies and approval points. For example, a failover plan may bring up the database cluster first, confirm replication, then enable application servers and update DNS, all triggered through a single workflow. Regular rehearsals ensure that the orchestration scripts remain current. Automation makes recovery repeatable, and validation ensures it stays safe. Together, they replace manual coordination with timed precision. Building further, cyber recovery vaults and isolation layers protect backups from compromise during cyber incidents. A recovery vault is a logically or physically separated environment that stores clean, immutable copies of data inaccessible from the main production network. Access is restricted, monitored, and often air-gapped, meaning it cannot be reached even by privileged accounts in the compromised domain. When ransomware strikes, these isolated backups remain the trust anchor for recovery. Periodic integrity checks verify the data in the vault matches known good baselines. Isolation is not paranoia, it is design prudence. A vault is the insurance policy that pays out when every other safeguard fails. From there, ransomware scenarios and restoration sequencing prepare organizations for the unique stress of malicious encryption events. Unlike hardware failures, ransomware attacks require verifying cleanliness before restoration. Restoration sequencing defines which systems return first and how to ensure they are free from contamination. For example, backup validation might include malware scans on restored images before reconnecting them to production. Communication systems and identity services typically come first so coordination can resume quickly. Practicing this sequence under time pressure exposes dependencies often missed in documentation. Recovery from ransomware is not only technical, it is a choreography of trust rebuilt step by step. Continuing that focus, backup encryption key lifecycle management ensures that protected data remains accessible but uncompromised. Keys securing backup data must be generated, stored, rotated, and retired under strict control. Key management systems or hardware modules can enforce separation of duties so no single person can both create and retrieve keys. Policies should define key rotation frequency and backup key escrow for emergencies. Losing an encryption key equals losing the data itself, so procedures must be tested regularly. Secure key lifecycle management proves that confidentiality and availability can coexist without trade-off. From there, maintaining backup catalog integrity and performing regular audits guarantees that recovery data can be found and trusted. The backup catalog is the index of what exists, where it resides, and when it was captured. Corrupted or incomplete catalogs turn valid backups into useless archives. Automated catalog validation should confirm entries align with actual media, paths, and timestamps. Audits should verify that restores match the catalog records and that obsolete entries are purged safely. For example, a quarterly report might compare catalog metadata to storage inventory, flagging discrepancies for review. Reliable catalogs turn restoration into navigation rather than exploration. Building on readiness, chaos experiments for continuity assumptions test how systems behave under controlled failure. Inspired by chaos engineering, these experiments intentionally disrupt components to confirm that backups, failovers, and monitoring respond as expected. For instance, disabling a database node or simulating storage loss can reveal gaps in alerting or orchestration. The key is safe scope. Start small, measure effects, and restore quickly. Chaos experiments transform continuity from a static checklist into a living discipline that evolves through evidence. Each failure taught under supervision prevents a future failure under duress. From there, metrics such as restore time objective, performance, quantify whether recovery meets the speed promised in policy. Measuring actual restore duration across drills and incidents shows trends, bottlenecks, and improvements. For example, if database restores consistently exceed their target by 30%, teams can adjust backup structure or increase bandwidth. Metrics provide transparency, helping leadership see that recovery capability is measurable, not theoretical. Over time, data-driven reporting shifts continuity from assumption to accountable performance. Continuing with measurement, metrics for data loss objective adherence verify how well the organization meets its recovery point goals. Each restoration test should calculate how recent the recovered data is compared to the time of failure. Tracking these gaps reveals whether replication frequency or backup timing needs adjustment. For instance, if transaction logs stop 15 minutes short of the event despite a 5-minute objective, monitoring thresholds may require recalibration. Adherence metrics connect business expectations to real outcomes, proving that continuity not only functions but functions at the promised level. From there, an investment roadmap with dependency sequencing keeps improvement deliberate rather than reactive. Each advancement, new replication technology, vault expansion, automation framework, should align to business priority and readiness. Dependencies determine order, catalog accuracy before orchestration, isolation before automation. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.